Okay, good evening. Okay, please keep quiet. Okay, we still have two more lectures in this subject. This is the last two topics. The first one is construction noise control. Refers to this one, we don't have many calculations refers to this topic. Okay, but in this subject, I want to share with you that we need to apply for noise permits when we use construction machines for general construction works or piling works. And I will let you know under what conditions we need to make application for noise permits. Please pay attention. Without a valid noise permits, we cannot do relevant activities during these sessions. Okay, now. We all know that the construction noise control is very fundamental because you know that when we conduct, perform, or carry out construction activities, it is necessary to use some power machines, okay, power equipment. For example, this is a construction site before we have a building block is adjacent to this innovations tower. Okay, actually, it's to control noise effects for construction work. It's rather difficult to control industrial noise because you know that industrial noise is normally an indoor activities, but for construction noise effects, it is generally for open area, open sites. Okay, so that even if we provide some sort of noise barrier surrounding this one, it is still hard to control the airborne noise effects and also the structural noise effects. When you refer to this one, industrial noise, normally we consider that this is inside buildings, and for construction works, this is for outdoor activities. And according to the British Standard 5228, construction and demolition works can pose different noise control problems. Meaning they are carried out in open areas, and they are a temporary durations. Because this is not a permanent effect, so that's why we need to have some sort of formal requirements to control these effects. And the noise that arises from many different activities because we cannot control the sequential use of machines because you know that sometimes workers could use all machines together at the same instance. So that it is very difficult to control this one. And the sites cannot be excluded by planning control as factory scans because we may install some materials inside industrial buildings. So how to consider this one? Okay, actually for those construction works, when we compare with the domestic renovations, we receive less numbers of complaints about this one. Let's take a look on a survey. Okay, this is a public survey that was conducted by this company, Wilson Hole and Associates Limited. This is a local acoustic company. Okay, they did a lot of innovations about how to do the controls in railway noise and in building constructions. They did a survey, public surveys about the construction noise effects. They interviewed more than 5,000 households to conduct face-to-face interview, and then they generate the survey results. Okay, let's take a look on that. After their study, they found that noise is concentrated during the daytime. Okay, not even at night. Okay, normally we make campaigns during the daytime, not at nights. And noise from domestic renovations is more annoying than general construction work. Okay, for general construction work, because we have some stringent requirements to control the use of power equipment or the time durations, we are allowed to use that. But for renovations, we don't have such stringent requirements for that. If your labor they want to do renovations at home, it is so annoying, and I just want us to control them to do that. Normally they can do this one during 9 o'clock in the mornings up to 5 o'clock in the afternoon. So that during this period you are not allowed to do this one, and so it induces a large number of complaints. And the final results they found that is the property management company could be a good channel to manage those renovations noise. Okay, this is the comparisons results. This is for domestic renovation and this is for general constructions. You can see that the light green one is not annoyed. Okay, but when you refer to this pie chart, you can see that more than 60% they could feel annoyance under the domestic renovations. But compared to the same situations in terms of the general constructions, only 40%. Okay. And also, this is the chart to show that the percentage of populations they could feel annoyance under the construction's noise effects, such as percussive power and general site activities, wall maintenance, demolitions. Okay, mainly during the daytime, not at nights. Okay, and with the presence of the PM is the property management. It is better to do control in terms of the for domestic renovations because when we receive complaints, we can this is a good channel for us to communicate with others. Okay, this is general information for your reference. So the numbers of construction sites in Hong Kong, I just extracted some information from the government's websites. Normally, we can divide into two types: the public sector sites and the private sector sites. Reference to 2019 up to 2020, even during the COVID period, the numbers of construction sites in Hong Kong was not less than 1,600. Okay, so that surrounding us, we have many construction sites, and also when we have new buyers or new renters in house, renovation is another major issue to generate noise effects. And this flow chart shows that what official departments they could regulate the noise effects. For the construction noise, it is you may refer to this one. It is relevant to the environmental protection departments because when we want to make noise permit applications, we need to submit a full set of documents to EPD. Okay, and then EPD could assess the information you provided to them, and they could issue a noise permit or not within 28 days working days. Okay, if we have this noise permit, it means that we are allowed to do some construction activities. If we cannot, if we are not allowed to do so, it means that you cannot. It is illegal to do that. We could not go through the details about that. Okay, I just want to share with you that in Hong Kong, normally we divide into two types. The first two types. The first one is general constructions work. In addition to that, we classify this as the parents work, and they have different requirements for general constructions work and percussive parents work. In terms of the legislations, we could refer to the Noise Control Ordinance, Chapter 400. To inside in this document, there are many legal terms about how to define the noise effects and what kinds of legal requirements we need to follow. And the descriptions of control, please pay attention when we want to use power mechanical equipment at night. Okay, from 7 o'clock in the evening. Okay, maybe now. Okay, to another day, 7 o'clock in the morning, we need to submit our permits when we use this one, when we want to use a power mechanical equipment. But for this one, during the daytime, okay, before this period, okay, let's say at 5 o'clock in the afternoon, we do not need to apply for any permits to use the power mechanical equipment, okay, just at night. It is very stringent. We need to have a very solid justifications, and even we need to provide very good provisions to reduce the noise effects. Otherwise, the authority EPD could not approve your applications. Okay, and for the parents, in terms of the parents, we still refer to the Chapter 400 Noise Control Ordinance. At night now. Okay, it is not allowed. Okay, even you submit an application to the authority, it is not allowed. Okay, it is prohibited. But in the daytime, during the daytime, when we want to apply the use of these machines, we still need to apply for noise permits. And there are two different types. I will let you know the requirements later on. Okay, in terms of the Noise Control Ordinance, it also refers to the industrial and commercial activities. Laboring activities. For the laboring activities, such as in the midnights, the control authority is the commissioners of police, not EPD. And the noisy products and the individual motor vehicles, they have the reference guidance. And also the traffic management and intruder alarm system. For this one, okay, intruder alarm system, what does it mean? It means that those alarm systems inside buildings, for example, the fire alarm system, okay, we have a specific sound level for this design, okay. If the sound level is too low, it cannot alert people for evacuations in case of fire accidents. If the sound level is too high, it is not good. So that's why we have this one. And the aircraft noise it is regulated by the civil aviation departments, not environmental protection departments. Okay, BS standard, there are two parts. The first part is for noise and the second part is for vibrations. This document is the core practice for noise and vibrations control, constructions, and open sites. There are some general control measures and suggestions at source. Okay, this is at source. Okay, and for example, we need to turn off unnecessary engines or switch off equipment where not required. Okay, it means that we do not turn on all equipment at the same time and keep internal hoods well maintained and avoid steep gradients. This is to transfer materials inside construction sites and use the rubber liners in chutes and dumpers to reduce impact noise, minimize the drop heights of construction materials, and start upfront and sequentially rather than all together. When you refer to all these general requirements, there are some common sense. Okay, reference to this one, I extracted two tables, one for general works and one for power works. Okay, there are different equipments here. Under different power rating, they measure the sound pressure levels at 10 meters away from this power equipment. Okay, you can see that this is the spectrum. This is one octave spectrum. When you dip into the data presenter here, you can see that at 63 Hz, the data is 80. Okay, when you take a look on the first type. But why the A rating sound equivalent level here is just 78? Why at this one, 63 Hz, the data is 80, but the total level, the A rated equivalent level is just 78 dBA. Why the equivalent level is less than the individual components here? Okay, when you read carefully about these two figures, two tables, the data here, the individual data here at 63 Hz is less than that to the overall level, the equivalent level. Why? Because the data presented from 63 Hz up to HK Hz, the unit is in dB, but the A-weighted sound level, pressure level is in terms of dBA. So this is the difference. You can check it by yourself. Okay, let's take a look on the first equipment. Okay, the first one, I copy the data here in blue color. You can see that. And then when we apply the A rating system to each component, these are the correspondence factors from 63 Hz up to HK Hz. You may refer to the lecture number 1 lecture logs. Okay, and you can see that when we add them together, this is the overall value. And then how to find out the A rating correction factor? This one. this is the overall value. So that's why you consider this value, the total level is less than that of the individual components in this case, because the units presented across the spectrum here and the final one, they are different. Okay, any problem? So when you refer to some similar guidelines, most of them they could present in this form. Okay, any problem about the calculations here? Okay, now another question for you. We have a question like this. We need to explain why our fabrics of 0.3 millimeter thick with STC. What does it mean, STC? Sound transmission class, okay? 15 cannot be used to reduce noise from an operating machine in a construction site by 10 dB if the fabric is used as a barrier. Okay, when you read through the questions here, you know, what does it mean? It means that we have a fabric, we use it as a barrier. And the fabric is that with STC 15, it means that at 500 Hertz, okay, the transmission loss of this material is 15 dB, correct? Do you still remember that how to find STC? This one, correct? In the lectures, I explained to you that how to find the STC, and even in your second lab, you focus on to find out the noise reduction index. Okay, so at 500 Hertz, we have a single rating here. Is that let's say STC 57? It means that for this material, you can reduce 57 dB at 500 Hertz. Okay, now the questions here is that now we have this fabric, and this fabric materials can achieve STC 15, but the answer is that in reality, we cannot use it to reduce 10 dB when we use it to cover, no matter you use it to cover or to block the sound effects generated from these operating machines. What is the possible reason for that? You may combine the basic principle of this one and the data here you observed in these two tables to answer these questions. Okay, please read carefully about these two tables. No matter this is for general construction machines or this power burst, what is the dominant effects? Low frequency, correct? Okay, you consider at 63 Hertz, the dB value is 80. Okay, although we apply the A ratings effects to this one. Okay, in the first lecture I told you that even we cannot hear, we are not sensitive to no frequency noise, but it doesn't mean that you could not make negative effects to us. Okay, so that across the whole spectrum here, the data in terms of dB at low frequency should be more polarized than that for high frequency, correct? Okay, to answer these questions, the first one is that STC rating of 15 dB, it does not mean that the transmission loss for all frequencies with 15 dB, okay, not all, just at 500 Hertz or above, you can achieve 15 dB transmission loss, correct? But what is the dominant frequency of the construction machines? Lower than 500. The frequency of construction machines usually below 500 Hertz, so you cannot make use of this one to block the sound wave for low frequency noise effects. So that's why it is possible that even we apply this fabric as a barrier, we can still not reduce the noise effects by 10 dB. This is the possible reason. Okay, according to the definitions STC here, we can only ensure that the effects at 500 Hertz or above, it can reduce 15 dB. But below 500 Hertz, we are not so sure that we can achieve this one. For construction noise effects, okay, construction machines, the dominant frequency noise effects is under 500 Hertz. So that's why this is the possible reasons why we cannot make use of this one to reduce the construction noise by 10 dB in this case. Okay. Any problem about the explanations about this one? And this is one of the past exam paper questions. Okay, now we go back to this one. For noise control ordinance, you deal with total number of 6 aspects. Okay, including noise from domestic premises or public places, construction activities, including parents, and even the intruder alarm systems installed in any premises or vehicles, and even the transportation vehicles noise effects is also under the noise control ordinance. Normally, for the airborne noise from construction activities, we group into two categories. The first one is general works, such as those excavations and concrete works, and the second one is the percussive parents works, such as when we use the hydraulic hammer or drop hammers. Okay, those relevant to parents works, we can consider into these two types. Potential ground-borne noise. Ground-borne noise, when I talk to you about the wave noise, I introduce this term to you. This is no frequency noise. Okay, this is one of the structural-borne noise effects, and some people could call this ground-borne noise. Even the construction noise under the tunnel borings or the operations activities, such as the railway services, operation services, it could generate the ground-borne noise effects. And this is a kind of regenerated noise inside buildings, and due to the transmissions or vibrations energy. And you may regard ground-borne noise as a kind of structural-borne noise. Okay, this is the machines. We call this is the tunnel boring machines or TBM. Okay, this is a tailor-made structure. Okay, we could not reuse this one. In every time we use this tailor-made structures to do excavations. Under the excavations of this one, you may regard this is an earthquake effect similar to the earthquake effects. There are 3 different types of waves generated. The first one is the surface wave. Surface wave is along the surface of the structure when you refer to the term here. The second one is the shear wave. Shear wave is a kind of transverse wave. Okay, in the first 2 lectures I introduced to use that acoustic wave is a kind of mechanical wave. We have 2 forms. The first one is transverse wave, and the second one is longitudinal wave. So now we still have transverse wave and the longitudinal wave under this one when you refer to the diagram here. Under the operations of this one, it can generate 3 types of wave effects. What I want to show you, this is an animations I extracted from the available informations. Some people call this one the compression wave is the primary wave, and this one transverse wave we call this a secondary wave. When you refer to this one, we have P wave and S wave. What I want to share with you, when you compare the speed, P wave is faster than S wave. You can see that. Okay, this one under the same time instant. Okay, the distance or the P wave is far away from the S wave, so that it means that the speed or the P wave is faster than S wave. But when you refer to the vibration amplitude, S wave is higher than P wave. Okay. So I explained to you before is that why we have an alert system for aircraft. We just make use of the time delay, okay, to trigger the effects. Remember, we cannot predict the occurrence of earthquake effects, but when we detect the presence of P wave under lower amplitude, it means that seismic effect is coming, and then we alert people to go to a safe place, okay? Because when you compare the vibrations amplitude S wave, the secondary wave, the transverse wave is much stronger or higher than that of the P wave, okay? So we use this one for generate the signal. Okay, tunnel borings. We use these machines to do the tunnel borings machines. Normally, when we talk about this one, tunnel borings machines, we could consider the effects of structural borne noise effects rather than airborne noise effects because it is under the ground surface. And we use it for explorations. In the past, we used explosive or other different techniques, construction techniques to do such kinds of activities. But now we normally use this one for metro train service or the underground tunnels construction works. Tunnel borings machines. This is a simple sections to show the internal variations of that. I could not request you to understand the functions of each of them just for your reference. What are the major components for TBM? TBMs typically consist of the rotating cutting head. This is the rotating cutting head. We call this is cutting hair followed by a main bearings. Okay, we have a bearings machines. It is a machine used to excavate tunnels with a circular cross sections, and the average working rate is 5 to 10 meters per day, and the length can be up to 100 to 150 meters. Okay, let me show you a very short video about how does the TBM works. when you look for relevant information about TBM, you can search much information you want. In addition to the circular shape, okay, originally, the geometry of TBM is similar to a circular shape, but now we have some types of rectangular shapes like this. Okay, this is the rectangular shape. Okay, so that's we are not restricted to circular shapes configurations only. It depends. We have different types of tailor-made structures. Okay, in terms of the TBM constructions, we may derive into 4 types: open type, shielded type, pressure balance, and the shower type. I could not go through the details about this one because this is not relevant to the geotechnical subjects. So I just want to let you know that in general, we have 4 types, and what types of we need to use, it depends on the geological properties or structures, whether this is hard rock or soft ground. If this is a hard rock, normally we use the shielded type or the open type. Otherwise, for soft ground, we may use another types. Okay, it depends on the geological properties of the structure. And in the past, in Hong Kong, many constructions, especially as we have many metro tunnels, we would use the TBM constructions because this is the effective way to do that. And as I told you before, each TBM is a tailor-made structure, tailor-made machine. Okay, this is list some examples here. And people they like use the historical female names to call these tunneling machines. Okay, you consider some of them like this one. And under different project requirements, the external diameters you consider range from 3.3 meters up to 9 meters, 8.8 meters. Okay. This information is not up to date, but just for your information. Okay, now to measure the ground-borne noise, one key parameter is the vibrations level. We call this one is ppv, and the unit is millimeter per second. When you look at this table, if the vibrations level is just 0.14 millimeter per second, this is not very sensitive. It's just perceptible. But if it is up to 5 millimeter per second, 10 millimeters per second, or even 20 millimeter per second, the damage should be applied on a building structure. Okay, because the vibrations effect is very rigorous. And ppv, this is a short term about the peak particle velocity. This is defined as an instantaneous maximum velocity that can be reached by vibrating elements. We use this one to assess the ground-borne vibration. Okay, technical memoranda. To assess the noise effects, we have 4 technical memoranda. Okay, in the first lab, I share with you one of them. Okay, to assess the tonal noise effects, and we still have other 3. And other 3, they are relevant. They are relevant to the construction noise permits, and they are used to assess the general construction works and the parent construction works. Construction noise permits. This is a legal document that should be applied. We need to the main contractor may submit relevant documents to the authority. The authority here it refers to the environmental protection departments, and the authority could follow those requirements presented in the technical memoranda to assess the effects. Within these documents, it contains technical principles that can be applied to determine whether or not permits should be issued and under what conditions should be included in the permits. We have 4 technical memoranda. Okay, we use this one to assess the effects of tonal noise. We still have these 3 technical memoranda. The first one is technical memorandum on noise from construction works other than percussive powering. The second one is for construction work in designated areas. What does it mean, designated areas? Those populated or urban areas. We call this as designated areas. Okay, this one. Okay, for example, if we have a construction site located adjacent to our campus in Jim Sa-Zui, okay, in Hong Kong here, we may consider the second one because our location is inside the designated area. And the third one is the technical memorandum on noise from percussive powers. The last one I explained to you before, so we do not consider this one again. Okay, in general, we just classify into 2 types, 2 categories. The first one is the construction work other than percussive powering, and the other one is for from percussive powering. What are the differences? Okay, not only for construction activities and also for demolition works, we still need to apply for noise permits. Okay, because sometimes for demolition activities, it could create louder noise effects when we conduct construction activities. When we have a guidelines issued from the buildings departments, this is called practice for demolition of buildings, and to do so, we need to apply for the noise permits. This one, the applications of such construction noise permits has to be submitted to the authority at least 28 days before the proposal commencement or any works to allow for the processing of these applications. That means if you intend to do relevant works for demolitions, you need to submit noise permits before 28 days. Okay. This table I extracted from the core practice here. When you refer to this one, they could classify noise vibration stats are the major pollution characteristics problems. Okay. Okay, to reduce the noise effects and the dust effects when we conduct demolitions, some countries they use some specific techniques for doing this one. Let me show you this one. The first one is the head-down methods. This one was introduced in Japan. Okay. And this head-down methods, we need to use the joint jacks and the electric generator clamps to mix noise and culture surrounding this building. Okay, when you take a look on this one, it can be reduced by 17 to 23 dB. And about the that's because all the construction works they did it inside the building, so that you can minimize the effects of the dust. Okay, let's take a look on this one.
Watch closely. This is not a magic trick. Instead, it's a remarkable feat of engineering, a clever way in the heart. We've gone from a height of about 138 meters to about 80 meters today. And how does this work? It's a delicate demolition, and it's quite very busy on the inside. 4x4 crews take out the beams and supporting columns. The debris is removed, then temporary jacks lower what remains. All told, the shrinking should take about 6 to 7 months. The downside to all of this, there certainly would be cheaper options when it comes to deconstruction. But this method is clean, it is efficient, and it's not disturbing the neighbors. Demolishing a structure can damage nearby buildings, and there's the noise, dust, and debris, Shikara tells us. And yes, he says, this is something that can be done just about anywhere in the world. A clever alternative that shows what goes up can come down, slowly but surely. Alex Holbert, CNN.
this is one of the techniques is the down methods, and the other one is the bottom up methods. This is alternative to the top down concrete demolitions at the top. Okay, let's take a look how it works. Normally we could do the demolitions at the top of the building, okay, rather than at the bottom. But now we can make use of this bottom up methods to do this one. Okay, reference to page 25, we may go to this one for easy reference. We have two types, general construction works and power work. For general construction work, during the weekdays, during the daytime, there is no restrictions for the use of the power mechanical equipment. For example, in the afternoon, okay, you do not need to make any applications for the use of the power mechanical equipment. But for power work, you need to make applications for that. And after several o'clock in the daytime, such as in the evenings, when we want to use power mechanical equipment for construction work, we need to make applications for construction noise permits. But after several o'clock at night, it is not allowed to do so for power work. Okay, even you make applications for that. Okay, the authorities could not approve your requests. So that's please pay attention. And the procedure normally it takes 28 days to have the final results. And when you submit the applications, you need to submit the locations plans and the numbers of machines you are proposing for the use in this construction works, and what kinds of surroundings the construction sites. What are the noise sensory receivers? You need to prepare a set of documents to the authority. Okay, for the construction works other than percussive powers, we have a total number of 13 procedures. 13. Okay, this is just for the assessment procedures for construction works other than percussive powers. So when we consider the use of the percussive power, we could not follow these procedures. We have another set of procedures. The first one, we need to locate the most effective noise sensory receivers. NSR. What is NSR? For those buildings, such as domestic premises, hotels and hostels, educational institutions, hospitals and clinics, all of them, we could classify they are NSRs. Okay, if there are no any sensory receivers surrounding the construction site, we don't care about this one. Okay, we don't care about the noise effects. Okay. This is the first assessment procedure. Okay, in table 1A, this is the area sensitivity ratings. Reference to the vertical column here, this is types of area containing NSR. Okay, we just have 4 groups. The first one is rural area, the second one is low density residential area, the third one is urban area, and the last one is area other than that. Okay, now let's say we have a construction site located surrounding us. Okay, we cannot classify the campus, our home campus is in rural area. We must in the urban area. Okay, it is based on the engineering practice, okay, or your judgments. So, and whether this is not affected, indirectly affected, or directly affected, it depends on the real situations. This is degree to which is affected by IF. What is IF? Influencing factor. Influencing factor. This is a short term. Okay, the second procedure is the determinations of the ASR, whether the types of area within which the NSR is located, such as rural area, such as urban area, and whether there are any other influencing factors, such as this is a traffic road located surrounding the construction sites, this is an industrial area, or there is an airport located surrounding us. For the influencing factors, how to define whether the traffic road makes significant contributions to NSR? If we consider a major road, if the traffic flow is more than 30,000 vehicles per day, we this one is regarded as a major road. Less than that, we do not consider that there are any significant effects to the NSR. Okay, and then we have some definitions about that. I just want to share with you these definitions, but when you read through all this one, sometimes you are difficult to understand how to define this one. It is based on the real situations. Okay, let's take a break first, and then we go back to the we go to the second part. Okay, let's come back. Okay, before the break, I told you before there is a term what we call the designated area. According to the guidelines, designated areas are reference to to an areas that control noise from general construction source. This is a built up or populated area. When you take a look on this map, okay, the authority defines that the deep green area, we call this is a designated area. Okay, along this one. And non-designated areas are those not built up areas or may include commercial districts, industrial zones, or similar less noise sensitive receivers. Okay, when we consider the surroundings NSR in urban areas, normally we take 100 meters radius around this NSR should be adequate. And for rural areas, we need to consider that within 500 meters. And then you can select the worst case scenario. If the worst case scenario can fulfill the requirement, that means that all other scenarios that can also fulfill the requirements. This is a simple example here. We have new construction sites. The construction machines we put it at the top of these locations. Okay, you consider there are 3 buildings, A, B, and C. The first one, building A, facing this direction, the pin line here, the dotted line here, it refers that there is no window, no any window. Okay, and on the other side, blue lines, the solid lines, it means that there are some windows. So when you compare the worst case A and B, which one is worse? B, correct? Because on this building facades, there are some windows. But when you take a look on building A, no any windows on these two sides. Okay, so when you compare A and B, B is the worst case. But when you consider B and C, although they are the same, okay, all 4 walls, building walls, they have windows. But the locations with respect to B and C, B is more closer than that of C. So that's the worst case in this scenario is building B. The second one is that the effect of influencing factor. We have a newly built construction sites here. If there is a road and the traffic flows of this major road is more than 30,000 vehicles, it means that this is we need to classify this as a major road. Under the major road effects, we consider building B is directly affected. Still remember that we have a number of scenarios in this table, A, B, and C. A, B, C. How to classify this one? It depends on the degree to which is affected by influencing factors. On the other case, although we have a construction site here and the building A on this direction and this direction, there are no any windows. And the road here is less than 300 vehicles. We could consider that the influencing factor is indirectly affected in this case. Okay, why we need to consider this one? Because we need to consider table 2A or the table 2B to find out the basic noise level. Table 2A is for non-designated areas, and table 2B is for designated areas. Okay, they're different. Okay, now. Basic noise level, all the days runs several o'clock in the evening to 11 o'clock in the evening. If we classify this as A, the basic noise level should be 60. In the midnight, this one should be up. The basic noise level is 45. When you compare table 2A and table 2B under the same time durations, okay, for A directly affected, this should be 45 only, but this one should be 60. This one is 50. This one is 65. This one is 55, and this one is 70. The difference. What is the difference between them? The difference between them is 15 dB, correct? Why the basic noise level in designated areas should be less than that of the non-designated areas? Why? We have two tables. Why we have two different sets of requirements for non-designated areas and designated areas. Designated areas are often in urban areas, correct? Whether we issue a noise permit or not, it depends on the basic noise level. If we set the basic noise level is lower, it means that the requirements to fulfill the legal requirements, the authority can issue the noise permits to contractors. It is more stringent. Okay. If we set the basic noise level is too high, maybe more than 80, it is easiest to satisfy these conditions, and then we can do the relevant activities. So the only the difference between them, non-designated and designated area, it depends that urban areas we need to have more stringent requirements. Okay, in such a way that the authority could issue noise permits to reference works. Okay, for rural areas, for non-designated areas, the influence effects, the negative impacts may be less than that when we compare with the urban areas. Okay, so this is the reasons why. And that is we marked here. The above table is used in the assessment of CMP applications for construction works using any power mechanical equipment. PME refers to power mechanical equipment located within non-designated area. And for construction works using PME other than SPME, what is SPME? SPME refers to special power mechanical equipment. S refers to special. Okay. For table 2B, another remark is that the above table is used in assessment of CMP for construction works using one or more of the SPME in construction sites located within DNA or DAS. I will let you know what is SPME later. As I told you, we have a total number of 13 procedures. So another 11 procedures. We need this is the list, the full list. The first one, number 3, is to determine the basic noise level from table 2. It depends on whether this is a non-designated area or designated area. Number 4 is the constructions or the durations of the construction's noise permits. Number 5, constructions for multiple permit situation, and then determines the acceptable noise level. Let me explain to you from number 4 to number 6 first. Okay, please go to this one. The acceptable noise level is equal to these equations only. Okay, ANL is acceptable noise level, BNL is the basic noise level. Okay, so that, as I told you before, the difference between the non-designated and designated area, BNL, is 15. Okay, so in urban areas, lower the basic noise level, it means that lower the acceptable noise level. So that's why the requirements in urban area are more stringent than that in non-designated areas. We have two other parameters. The first one is CP. What is CP? This is the correction for permit duration. What does it mean? It means that if the work is not more than or equal to 14 days, okay, CP is equal to 3 dBA. 3 dBA. It means that they give you a bonus about that. Okay, the higher the level, the easier we can achieve the requirements. So if it is not more than 14 days, CP is equal to 3 dBA. Okay, how about the CM, multiple site situation? Let's say this is NSR. Now we already have two existing sites. Okay, they are working together. Now we have a new application sites. Okay, we still need to consider the negative impacts for these two existing sites. Okay, and then we make the authority could make corrections to the basic noise level based on the real situations. How to do this one? We just make use of the standard acoustic principles to do analysis, and the range is normally -1 to -7 dBA corrections. Okay, this is the typical range. So BNL is selected from table 2A or table 2B. CP, it depends on the time durations for your work, and CM is the corrections for multiple sites situation. Okay, whether there are more than one construction sites working together. So you just add up all these three parameters together, you can get the acceptable noise level. Okay, and you can complete. So far, you can complete the item number 1, the assessment procedure number 1 to 6. Okay, now for procedure number 7 to 12, the first one is the locations of items of power mechanical equipment. It means that you need to prepare a full list of mechanical equipment you could use in your construction sites for your construction works. So they could base on this ones to do assessments. The second one is sound power levels for the items of PME. They have a list to show the sound power levels for this PME and the distance attenuations, corrections of barrier effects, corrections of acoustic refractions, and then they find out the corrected noise level. Okay, based on what requirements they could issue a noise permit or not, they could compare the values ANL and CNL. Okay, if CNL is less than the acceptable noise level, it means that the noise permits can be issued. If the corrected noise level is more than the acceptable noise level, the permits could not be issued. It means that you cannot conduct relevant works. Okay, until you can share the information to support that the corrected noise level is less than the acceptable noise level. So you may regard there are two parts. The first part is to find out the ANL. Okay, ANL is based on these three parameters. For the second part, we need to assess the effects of the power mechanical equipment. All of them I show here, such as the concrete mixer, dump truck, and roll roller. All of them we could divide the power mechanical equipment. And according to the technical memorandum, they have this table. Table number 3 is that, for example, when we use a breaker for relevance works, this is the identification code CMP023, and the sound power level is 108. Please pay attention. This is sound power level, not sound purchase level. Okay, they are different. Sound power level, it depends on the original acoustic source. And some equipments, they could consider that this is a specific power mechanical equipment, such as handheld breaker, bulldozer, concrete lorry mixer, handheld vibration pocket. All of them, they could consider this is SPME. And then this is the summations of noise level. Because you know that we may make use of more than one equipment at the same time, so that's when we want to consider two different sources, you can consider the use of this one. How to make use of this one? For example, if we have two signal. One is 72 dBA and the other one is 75 dBA. Okay, if you want to find out the overall results, it is very easy. You just use this one, 75 minus 72. The difference is equals to 3 dBA, correct? 3 dBA according to this one. The difference in dBA between two noise sources being summed is 2 to 3 dBA. So that's we can guess the correction factor is 2. Please pay attention. 2 must be always applied to the highest level. So 75 plus 2, it means that the total level it becomes 37. Okay. This table is not just for two sources. Okay, more than 2 we can still use it. For example, we have 3. Okay, one is 72, the second one is 75, and the other one is 76. Okay, you may consider the first two. The difference between them is 3, correct? And then reference to this table, the correction is 2, so that's 75 plus 2, it becomes 77. And then you compare 77 and 76. What is the difference between them? 1, correct? So you select this one, and 2.5 is applied to the highest one, so it becomes 79.5. Okay. We do not need to use calculators to do the summations of that. We just refer to these 2 columns. We can find out the overall results. This is the distance attenuation, and this is a table. You can refer to this one. Table 5 is the correction factors to obtain the predicted noise level from sound power level at given distance. Let's say the distance between the receiver and the machines, and these machines, let's say is 5 meters. 5 meters. Okay. The correction factor, please bear in mind, all the values highlighted here are negative values because the longer the distance, the lower the sound purchase level. Correct? Please pay attention. All the data in red color here, they are negative value, not positive value. Okay, and then this one is just up to 300 meters only. Okay, more than 300, you can do calculations by yourself using some standard acoustic calculations. Okay, now let's take an example here. We have 2 machines. One is CMP023 and the other one is CMP030. Okay, one is 50 meters away from this NSR and the other one is 20 meters away from this NSR. How to consider this effect? Okay, we have 2 machines. The first one is this one, the breaker, and the second one is the poker. Okay, please bear in mind the sound power level for the first one is 108 dBA and the last one is 113 dBA. So when you refer to this one, the separation distance, one is 15 meters, correct? So the correction factor is minus 32, and the second one is 20 meters away from the NSR, correct? So the correction factor is minus 34. Okay, so the predicted noise level based on tables 3 and 5, CMP023, the sound power level is 108 minus 32. This is the sound purchase level, 76 dBA. For the second machine, CMP030, the sound power level reference to the table number 3 is 113, and table 5, the separation distance, the correction factor is minus 34. So the correction is 79 dBA. What is the total level? You just need to compare the difference between these 2. When you compare this one, the difference is 3 dBA. 3 dBA, when you refer to this table, the correction factor is 2. So that's why the predicted noise level at NSR is 81 dBA. Okay, this is the total one. Okay, we just follow table number 3 to number 5. We don't need to do any calculations. Any problem about this one? Okay, for the barrier, when you refer to this one, we need to consider that whether we install barrier along the NSR. If we have, we may make use of this correction factors to do analysis. Minus 10 dBA. Reference to this one, please pay attention. This is for diffractions effects. Diffractions. Okay, at the top, the balance of sound wave over the top of this barrier. But please pay attention whether the position is correctly installed. This one we consider that it could make functions effects to it is workable to the NSR, but this one is not workable. And the final one is the corrections applied to PNL, because you know that no matter for road traffic noise, railway traffic noise, and even for construction noise, the assessment point is 1 meter away from building facades. So that's because the building facade is a hard surface, is a reflective surface. So they propose the use of positive 3 dBA as a correction factor. When you refer to the calculations of road traffic noise and calculations of railway traffic noise, they propose the use of 2.5 dBA. Okay, but no matter you use 2.5 or 3 dBA, it is very similar. So this is the summary table to compare the value of the acceptable noise level and the corrected noise level. In terms of the acceptable noise level, we care about the parameters and the factors such as the area type. ASR refers to table A, 2A or 2B. The second one is inference factor. The third one is the time durations of day. We could do this reference activities. In terms of the correction factor, we need to consider the CMP duration, CR, and the multiple sites. Okay, whether they are multiple sites. And the typical values for the second parameter is from -1 to -7 dBA. Okay, and then when you add up all of these factors together, we got A and L. On the other side, on the right-hand side, this is the corrected noise level. First, we need to highlight the total sound power levels of each power mechanical equipment. And then we need to consider the distance attenuation, noise screening, and acoustic reflections. Okay, in terms of this distance attenuation, you can check this equation. This equation is exactly the same as this table. Okay, but please pay attention that they assume that even the source, the NSR is very close to the source. Okay, they just make correction factor minus X dBA. But for those factors presented in this table, you can make use of this equation. Okay, this equation, actually you learned this one before. Okay, let us go to this one first. How to find out this one? How to get the distance corrections like this equation? R is the directions between the source and the receiver. Okay, when we put our machines on the ground, okay, we need to consider the directivity factor. Still remember that what is directivity factor? Okay, it can only radiate some fields in human spherical form, correct? If we put it on the floor, if we suspend a sun source, if we consider that this is a point source, it can radiate in all directions. So if we consider this is a human sphere, the surface area, it becomes 2 pi r square, not 4 pi r square. So based on that, I is equals to power derived by surface area is equal to p square over rho c. I experienced this one before and derived mathematically to you one by one. So when you follow the steps here, we can get the final result here. Please pay attention for this term. This term is very small, very small. We can ignore this one. We can ignore this term. Okay, you can substitute by W reference is equals to 1 times 10 power to minus 12, and P reference is 20 times 10 power to minus 6, and rho is the density, or ASE is the speed of sound. When you put all these 4 values into this term, it is approximately equal to 0. Some of the reference books, they could also take care of this one, but most of them, we can only ignore this one. So that's we just have, this is the standard form for the sound purchase level. This is for sound power level, and this one we can write it into this one. So this is the distance attenuation to connect the sound power level and sound purchase level. This one we regard this is the distance attenuation correction. Okay. But please pay attention here. This one is we assume that we put our machines on the floor and the directivity factor is equal to 2. Okay, now we go back to this one. So the CNL, the corrected noise level, it depends on the sound power level, the distance attenuation factor, the screening correction factor, and CR is the acoustic reflections. And then we can compare ANL and CNL. There are 2 conditions here. If CNL is less than or equal to ANL, the authority could issue the noise permits to us. If this CNL is larger than ANL, your application is rejected. Okay. Okay, now there is an exercise for you. Construction noise generated from a building sites that can affect nearby residential flats. The noise effects from 2 power machines A and B. The sound power levels are given here, and the operations time, one is for 4 hours, and the other one is 1.8 hours. The direct distance from the machines to the receiver is 29 meters, and the other one is 35 meters. You have to find out the overall A rated for 8 hours at the receiver due to these construction sites. Okay, please take about 3 minutes to complete this exercise. There is a remark here. We assume that the machines are installed on the site ground to radiate sound field in a hemispherical pattern, and there is no restrictions wheel from each machine to the receiver. Okay, they could not make interference with each other. Okay, let's take a look how to get the answers for these questions. We just have two equations. We just have two machines. Okay, these equations I extracted from your previous lecture logs. Okay, you can see that this is the equations to show up the relationship between some pressure level, some power level. R is the direct distance between the source and the receiver, and Q here is the directivity factor. Okay, now because this is we just put it on the ground, so Q should be equal to 2. Okay. For the first one, some pressure level, some power level is 102, the direct distance is 29, and the directivity factor is 2. So that's the some pressure level for machine A is 64.76 dBA. How about the second one? For machine speed, we apply the same equations, but just substitute different values for some power level and the direct distance, so that the second one is 66.13 dBA. Okay, please pay attention, this is just an individual some pressure level for each machine. How about the overall equivalence level at the receiver? At the receiver, we need to consider the operations hours for each one. For the first type, it operates for 4 hours. For the second type, it operates for 1.8 hours. Because I request you to find out the 8-hour A-weighted equivalence level, so that T here should be equal to 8 hours. So this is the equivalence level, 63.84 dBA. Okay, this is the standard equation. Okay, let's move on. Okay, the second one, we completed the assessment procedures for general construction works. How about the second one, the percussive pulse? Okay, pulse works is more intensive and short durations force, and it could create higher intensity noise effects. Compared with the previous one, the previous technical memorandum, the assessment procedure for percussive pulse, we just have 10 assessment procedures only. Okay, 10 procedures instead of 13 procedures. The first two, they are the same. The first one is to find the locations of the most sensitive receiver. The second one is to determine the ANL. From 3 to 9. Okay, let's take one by one. Take a look. The third procedure is some power level for percussive pulse. The third one is summations of noise level, distance, and attenuations. And then you go to number 9. Number 9 is different. Number 9 is specifically for the assessment procedures for pulse work. This is to determine the permitted hours of operations. Okay, what does it mean? Let's take a look on that. To find out the ANL, we may refer to table 6. Table 6 is the acceptable noise levels for percussive pulse. It depends on whether NSL with no windows or other openings. If there are no windows or other openings, the ANL can be up to 100 dBA. If with central air conditioning systems, the ANL should be 90. Similar to this one, this is we installed central air conditioning system, so that's why the acceptable noise level is 90. And if the NSL with windows or other openings but without central air conditioning system, the ANL should be 85. But there is a remark here. ANL should be reduced by 10 dBA for hospitals, medical clinics, educational institutions, cause of noise, or other NSR which are considered to be particularly sensitive to noise. Take a very sample here for this room. Okay, we have central air conditioning system, but the purpose of this one is for educational purpose, so that's the ANL is 90 minus 10. Okay, it should be 80 only. Table number 7 is some power levels for the percussive pulse. We have the diesel hammer, drop hammers, hydraulic hammers, and pneumatic hammer. And then table number 8 is correction factors for predicted noise level due to the distance and attenuations. Please pay attention. All the data presented in red color here, they are negative values, but this table number 8, is not the same as table number 5. Not the same as table number 5. When you compare these two tables, the data presented here, they are different. This table number 5, we can use these equations to find out the correction factors for table number 5 only, okay? Not for table number 8. Table number 8, we cannot just consider that this is a simple point source, okay? Because this is pulse work, different from a general construction work. So this equation, 20 knot hour plus 8, is just for table number 5 only. Table number 5. Please do not use these equations to find out the data presented in table number 8, okay? They are different. Okay, and then table number 9-8, please pay attention here. This is permitted hours of carrying out of pulse works, not involving the use of diesel, pneumatic, or steam hammer. Okay, what does it mean? When we use, they have different types of pulse types, such as the diesel hammer, drop hammer, hydraulic hammer, or pneumatic or steam hammers. If we just consider the drop hammers here, such as steel ship pile, we refer to table number 9A. Okay, you can see that if you compare the CNL minus ANL more than 10 dBA, okay, we can only allow it to do pulse works in this time period. If CNL minus ANL is less than 0 dBA, okay, we are allowed to do pulse work at several o'clock in the morning to several o'clock in the evening. If we fulfill the conditions here, we are allowed to do the time periods within these 5 hours. If we satisfy these conditions only, we are allowed to do 3 hours only. Okay, it depends on the conditions here. And we still have one more table, it's table 9B. This one is the use of diesel, pneumatic, or steam hammer. If we use this type, we follow these two conditions. You may rearrange this one for easy reference. Okay, you may rearrange this one if ANL minus CNL less than 10 dBA. Okay, you put the right hand side to the left hand side, and the minus 10 dBA you put it from the left hand side to the right hand side. It's more easy for our reference. Okay, if ANL minus CNL is less than 10 dBA, you are not allowed to do so. If we put ANL minus CNL more than or equals to 10 dBA, we are allowed to do relevance reverse during the time periods here. Okay, you may rearrange the sequence here for easy reference. So there are two tables, one for table number 9A and one for 9B. Okay, it depends on what types of parents equipment you're going to use to reduce the noise effects. Okay. Okay, and the limitations of the noise control ordinance. From the daytime, we do not need to apply applications for noise periods, so that the types of construction activities to be carried out and the numbers of equipment to be used at the same time. These are the limitations under the existing control ordinance to create the noise effects. Okay, and some people propose the use of the quiet equipment. Okay, I will show you some videos before the end of this lecture about how to reduce the noise effects. Okay, this one is to, oh, not this one. Okay, this is the magnetic tuner mass damper. It is used to reduce the parent's work machine. Okay, parent's machine. This one without the installations of tuner mass damper. This one they installed the tuner mass damper attached on this power machine. This one is to use the tuner mass damper attached on the parent machines. Okay, tuner mass damper, we apply this one in different areas. For example, in building, okay, you can look for the tuner mass damper such as in Shanghai Tower, such as in 101 Taipei building, okay, or even we apply these technologies a lot to construct the well dampers, okay. And the other one is the retractable barrier. In construction sites, normally we cannot build a permanent structure surrounding them, okay? So that retractable and movable barriers are more effective for use. Okay, let's go back to this one. I just list out some of the quiet equipment for your reference here. And then we still have other quiet constructions first, such as we use the acoustic enclosure, specific design noise enclosure, and use the hydraulic parents hammers that can be able to reduce 2 to 9 dBA as compared to other traditional parents hammer. Okay, and this one is the retractable barriers I presented to you for this video. Okay, and if you are interested, you can take a look on the product specifications about that. Okay, this is the end of this topic. Okay, after the break, we could go to this tutorial. This tutorial is still the road traffic noise. Before the break, let me show experience first to this one. You can see that there are two segments here, segment 1 and segment 2. We want to find out the effects from segment 1 and segment 2 contributed to this receiver. We know that we can calculate according to the calculations of road traffic. We understand that the direct distance between segment 1 and R is this one, correct? But for segment 2, we cannot classify the direct distance from this one to R, okay? The road must be in parallel with respect to R, okay? So how to handle these scenarios? They propose that to create two imaginary receivers, A and B, okay? Both of them, A and B, are not real, okay? Just R is real. But now, when we encounter these situations, when we need to apply the principles of the calculations of road traffic noise, we create this A and B. We first calculate A and B and then take an average of these two levels. We can find out the values of R. And for segment 1, the contributions to R to A, this is the first angle, 132 degrees. Segment 2 to A is 12 degrees. For the second one, segment 1 to B is 93 degrees. The contribution segment 2 to receiver B is 27 degrees. Okay, you follow the same procedure I presented in the last lecture, okay, to you, and then you can solve the problem. Okay, let's have a break first. Okay, you may start considering these tutorial questions, and then I will explain the answers to you after 30 minutes.
約1000個。
Okay, please take about 25 minutes to go through these questions.
一係即係通，即係通常，即係你個時間幾9千，即係3萬5千，除四就變咗9000，就換咗單獨換咗幾多錢俾你。但係佢2.2。
即係其實就唔使下算，即係如果呢題就根本就唔使下算過歷三，因為都已經係啲分咗嘅，因為 Q 嗰單嘢都通過歷三當時最 Q 係嗰個係啦，所以佢 call 嘅時候即係俾個二手嘅，所以我就話呢度就咪接受落去就話呢嚿呢睇嘅人次添啊，係啊，只不過你就係 Q 嗰啲即係呢個即係阿孫，因為我就之前睇過阿孫，因為咁見佢睇嘅阿孫自己有。有啲啊，呢個叫做多咗佢，有都係嗰一 part 啫嘛，係佢特別係嗰呢個嘢係咯，因為但係 X 呢個 flow 都係好細㗎，X 呢個係啊，X 呢個係好細嘅，就其實話呢可以直接可以唔使咁樣，所以我覺得佢嗰啲唔係乜嘢，所以呢度有寫有計，我因為佢要計翻個 Q 得出嚟，所以就轉過來，跟住之後呢個就要寫翻落去，即係呢個就應該係食俾你標出場，呢個100度嘅油仔嘅，即係你今次係標得就係等於1000歐法啦，你計翻我啦，可以除啦，等於翻到呢個1000除翻3個即係1000歐法1萬，我睇到1萬 mg 1000係 kg，跟住1萬2佢哋叫我哋做但係嗰啲翻去翻到好快嘅啦呢個。我哋睇個啲單位嗰啲係CSE嘅版本。
Okay, let's go to the last part. When we first do this one, when we first do these questions, okay, I want to remind you, I want to reiterate why we need to create these two imaginary points. Because in this case, when we refer to the CRTN documents, we can only assess the horizontal distance between the row number 1 to this reception points. Because row number 2 is on the same line with the reception points out here. So we don't know what is the direct distance between row number 2 to the reception points. So that's why they propose an alternative approach is to create two imaginary points here. Okay, and the separation point should not be less than 4 meters. Normally we take 10 meters for our calculation. So that it creates A and B. When you compare the scenario in this case with respect to this case, you can see that they are similar to each other. Okay. Now we just assess the assessment points are under the effects of segment 1 and segment 2. And according to the information provided from these questions, both segments, they are sufficiently long. So that's why the angles here, you can see that for segment number 1 is tangent from this point, this parallel lines to this point. Okay, the first one is 142 degrees, and the second one, due to the segment number 2, is 12 degrees. All of the angles they are given, and the information for segment number 1 and segment number 2, they are also given here. Please pay attention. In addition to the 10 meters here, we still need to count this 3.5 meters because the effective source we assume is this one, this line. Okay, so the total separation distance between this reception point A and the effective noise source is 30.5 meters. Okay. So for segment, so how to consider this one? We may derive into two segments, segment 1 and segment 2. But for each segment, you still need to calculate the effect from segment 1 to A and segment 1 to B. Similarly, for segment 2, you still need to calculate this segment to A and this segment to B. Okay. Okay, I assume that all the information are given here. How to do this one? The first step is to predict L10 for 18 hours. This is requested in the questions. Okay. Normally we take 1 hour for our measurements. We're at our reception points 1 meter away from the building facade and 4 meters above the ground. The second one, according to the documents, because the road is curved and it's approximately by 2.9 segments, so that's why we need to derive into two segments. And the information here I just copied from the documents. And the basic noise level, the speed limit in this case is 50 km per hour. There is no road gradient, so no adjustment delta V. Okay, if there is a gradient, we need to consider delta V here. This is just to consider upward flow. For downward flow, we do not need to consider this one. And the road surface is imperfect, and our surface correction is required as the traffic speed is less than 75 km per hour. So we list out this table. Okay, how to read this one? This is for segment A. This is for reception point A, reception point B. Okay, because both segment 1 and segment 2, they could make contributions to reception point A and B, so that you need to calculate one by one. The traffic flow, according to the information here, is 9,500 vehicles per day. Okay, under the durations here. So reference to chart number 3, you can calculate the basic noise level is this one. Okay, all of them are the same because all the traffic flow, they are the same coursing through these two segments. The second one is the traffic speed. Both of them are they are 50 km per hour. So that's when you refer to chart number 4, the correction factor is 0.2 dBA under the percentage of heavy vehicles 10%, and there is no road gradient, so we do not need to consider delta V. How about gradient? The gradient percentage is 0, so that's why the correction factor reference to chart number 6 is 0, and the road surface imperfect is -1 dBA. Okay, you can see this one. Okay, the first one. If the speed is less than 75 km per hour, the correction factor is -1 dBA. Okay, and then you can add all of them together. Okay, in this case, reference to the first two stages to find out the basic noise level, all of them are the same. Okay, under the same traffic flow, under the same traffic speed, percentage of heavy vehicles are the same. Okay, how about the first stage? The first stage is the propagations effects. Okay, please pay attention here. The shortest distance between segment 1 to A should be 27.5 plus 3.5. You may refer to this figure. Okay, this is 27.5, but the effective source is located 3.5 meters away from this distance, so that the total length should be 27.5 plus 3.5. And how about this one? This one should be 10 plus 3.5. Okay, the relative height about the effective source is 3.5 meters because we assume that the effective source is 0.5 meters above ground, and the average height of propagation is 2.25. This is given in the question. Okay. And the ground cover I, the value is equal to 1. So that's based on chart number 7, we got -3.6 for segment 1 to A. For segment 2 to A, this is equal to -0.1. The difference between the distance is different. Okay. For the ground cover corrections, they are different because the direct distance, they are different. Okay. And then you add up together, you got -5.7 for segment 1 to A. For segment 2 to A is -0.4. Okay. For details, you may check chart number 7, chart number 8, and chart number 9. And how about the angle facade corrections? In terms of the facade corrections, please pay attention here. Opposite facade, we do not consider the opposite facade as stated in the questions. But for the angle of view, for segment 1 to A is 132. For segment 2 to A is 12. Okay, you may refer to the diagram. For segment 1 to B is 93 degrees. Segment 2 to B is 27 degrees. So that's when you refer to chart number 10. Chart number 10, you can find out the correspondence values here. Okay, this one. Yeah, difference. Chart number 10 is this one. You may go to this one. This is chart number 10. Angle of view. So you got other data for site layout. How about the combined noise level? For the combined noise level, you just consider from stage number 2, stage number 3, stage number 4, and then add all of them together. And how to calculate this one? Combined noise level 64.7 because they are both segment A and segment 1 and segment 2 to contribute to the receiver A. Okay. So when you want to calculate this value, how to calculate this one is 10 not. This one is 63.6 divided by 10 plus. Another one is 58.4 divided by 10. Okay, you can get this value. And the other one for segment B, for the receiver B, under the segment 1 and segment 2, we got both of them is 62, so that the combined level is 65 dBA. So this one, the last row here, this is the average noise level at R, the receiver R, the real receiver. You just get an average for both of them. We can get 64.9 dBA. Okay, this is the final results at the reception point R. Okay, please pay attention. The last procedure, you just get an average for A and B only. Okay. But this one combined noise level due to segment 1 and 2 to A, you need to make use of this equation. Any problem? For details, you can check the charts in your lecture logs one by one. Okay, I will share with you these solutions on next Monday. Okay. Okay, thank you. In the last lecture, I will tell you about the examination formats. Okay. The format of your final exam is a little bit different, okay, with respect to the previous years. So I will tell you later on, okay.